What's going on, Algebra 1? How are we doing this week? This week, still another week of our online learning. Let's see, it's week 4, okay? And unfortunately, last week we got the word from Governor DeWine that we're not going to physically be back for the rest of our school year, which is kind of sad, okay? I promise we're trying to figure something out for you all to sort of celebrate promotion. We'll be thinking about something. If you have any ideas, just let us know, okay? But this week, we are still working with quadratics, okay? So far, we have solved quadratics by taking the square root. We've solved quadratics by factoring. Now it's another way to solve quadratics. In this case, we are learning this week about the quadratic formula, okay? So, without further ado, let's get to the video and see how it works.
How are we doing, algebra? This week we're going to be talking about the quadratic formula, and I wanted to start off again with what the basics or what the original function of a quadratic is going to look like, because it's very important that we know each part in order to effectively use the quadratic formula. So we need to remember that our a term is always connected to our x squared term, our b term is always connected to our x term, and our c term is always our constant. Now, with this in mind, let's take a look at the quadratic formula, because the quadratic formula is going to use each of these parts, A, B, and C, in order to use it to factor. Okay, so the quadratic formula, if a function of x equals ax squared plus bx plus c, and a is not equal to 0, so a could be any number, then you can use this formula of x equals the opposite of b, or negative b plus or minus the square root of b squared minus 4 times a times c. Everything is divided by 2a. Now, again, you're going to want to have a calculator when you're trying to do this, because this is a lot to try to do on your own. And in fact, I've got a calculator next to me while I'm doing this, because things can get a little bit tricky sometimes. Okay, so if you need to take some time to rewatch this, definitely go ahead and do that. It might be good to watch it the first time and take notes, and then the second time just to try to figure out what exactly is going on, because sometimes you can miss things. But let's try to use this in a second, but I've got one more thing I need to tell you about this. So everything that is under the radical right in here, b squared minus 4ac, that actually has a special name to it. That's called the discriminant, okay? And the discriminant can be used to help determine the number of solutions of a quadratic equation. So if b squared minus 4ac, if that number is greater than 0, then we know for sure that that quadratic has two real solutions. If b squared minus 4ac equals 0, then we know that it's only going to have one real solution. And if b squared minus 4ac is less than 0, then it's going to have 0 real solutions. However, if it has 0 real solutions, that doesn't mean there are no solutions, because there are such things as imaginary solutions with imaginary numbers, and we will talk about those later on. Okay? So now, let's try to use the quadratic formula in order to help solve or factor some quadratics. So in this first example, example A, I have x squared plus 4x minus 32. Now the first thing that I'm going to do is I'm going to label what is my A, what is my B, and what is my C. So that way I can effectively use it going forward. So I know that my A is going to be 1, my B is going to be 4, and my C is going to be negative 32. So let's think about this, or let's use the quadratic formula when I'm trying to do this. So it's the opposite of b, so negative 4 plus or minus b squared, so 4 squared minus 4 times 1 times negative 32, and all of that is underneath the radical. All of that is divided by 2 times my a value, which is 2 times 1. Okay, so I'm going to simplify this a little bit. We have negative 4 plus or minus 16 plus 128, all of that over 2. And I can simplify this a little bit more. So this is going to be negative 4 plus or minus, let's see, this is going to be 144, the square root of 144, over 2. And this actually becomes negative 4 plus or minus the square root of 144 is 12 over 2. So now this is where I get into my answer section, okay? So I have negative 4 plus or minus 12 all over 2. I can get my two solutions. One of them is by adding by 12 in my numerator, and the other one is by subtracting in my numerator. So that means I have negative 4 plus 12 over 2, or negative 4 minus 12 over 2. So negative 4 plus 12 is going to be 8 over 2, which equals 4. Or negative 4 minus 12 is going to be negative 16 divided by 2, which is going to be negative 8. So my two solutions are x equals 4 or x equals negative 8. Okay, so that's our first example. Let's try to go back to the second one. So the first thing I need to do here for 4x squared minus 27x equals 40 is I need to get my constant to be on the other side. I need to have my quadratic equal to 0 when I'm using the quadratic formula. Okay, so now I'm going to rewrite this as 4x squared minus 27x minus 40 equals 0. So now I can go forward and label what is my A, B, and C. So my A is 4, my B is negative 27, and my C is negative 40. So let's put this in the quadratic formula. So I have my opposite of my B value, so 27 plus or minus negative 27 squared minus, oops, that's a minus sign, 4 times 4 times negative 40, and all of this is underneath the radical, all of that over 2 times my A value, which is 4. So let's do this. I'm going to try to simplify in each part. So I have 27 plus or minus 729 plus 1,000, plus 640, square root of all that, over 8. And I'm going to move on to the next slide, or I'm actually going to go to my own slide. So I'm going to copy and paste this information. Let's see. Copy. Here we go. So this is going to become, I have 27 plus or minus the square root of 1,369 over 8. And actually the square root of 1,369 is 37. So this becomes 27 plus or minus 37 all over 8. So let's get into my two solutions. So I have 27 plus 37 over 8, or 27 minus 37 over 8. Okay, so 27 plus 37 is 64 over 8, which is just 8. And then 27 minus 37 is going to be negative 10 over 8, which is just negative 5/4. So it's either x equals 8 or x equals negative 5/4. Those are my two answers. Okay, now let's try this in a real world situation. Use the following object model: h equals negative 16t squared, where h null, that little 0 in the subscript tells me it's null, where h is the height in feet of the object after t seconds, and h null is the object's initial height. A person is trapped in a building 123 above the ground and wants to land on a rescue team's air cushion, which is 3 feet off the ground. How long before the person reaches safety? So in this situation, I need to put in numbers into the right spots. So I know that my final height I want to be 3, and that's going to equal negative 16t squared plus my initial height of 123 feet. So again, I need to make this be equal to 0. So I'm going to subtract by 3 on both sides, so I get 0. Oops, that doesn't really look like a 0. There we go. 0 minus 16t, or equals negative 16t squared plus 120. And now I have enough information for me in order to write what my A, B, and C is, or what they are. So my A term is going to be negative 16. My B term, I don't see that I have anything that has a regular t with it, okay? So if there's nothing there, in this case, it's a 0. So my B term is actually a 0. And then my C, or my constant in this case, is 120. So let's put this into the quadratic formula, so that way I have what I can work with. So I'm going to have 0 plus or minus the square root of 0 squared minus 4 times negative 16 times 120. All of that over 2 times negative 16. So let me simplify this a little bit more. So this is going to be 0 plus or minus the square root of 0 plus 7,680. All of that over negative 32. So let me just move this over to the left here. This ultimately becomes rewritten to be plus or minus the square root of 7,680 over negative 32. So that's not my final answer yet. I got to do some more work because I want to be precise, because I don't know what the square root of 7,680 is, and nobody is going to know that off the top of their head. So I need to break this down into both my positive and negative answer. So it's either going to be the square root of 7,680 over negative 32, or the negative of 7,680 over negative 32. And when I go ahead and put this in the calculator, I get that my x, or my t, let's just make this t to keep it consistent in the problem, t equals negative 2.74, or t is positive 2.74. But let's think about the context of the problem in this case. I'm looking to find out how much time it takes before the person reaches safety. How long before the person reaches safety? My time is going to be in seconds. Now, if we look at my two possible answers, I could have a time of negative 2.74 or a time of positive 2.74. But in this situation, I can't have a negative amount of time. I'm not allowed. There's physically not a way that we can have negative 2.74 seconds. So in this situation, this answer of negative 2.74 is not realistic in the context of my problem. So I can eliminate that answer and say with confidence that it's going to take roughly 2.74 seconds for a person to fall from 123 feet down to 3 feet. Okay? So those are all of my problems that I have for you, and I'll scroll back up to the quadratic formula.